Moving on to the fresh concept, fraction as a part of the group. Children, till now we had learnt a fraction as a part of the whole or as a part of some collection of items as such. But now we shall study about the concept of fraction as a part of the group. If you observe the picture mentioned here, it's very clear that I'm talking about or I'm referring to a sweet shop. So sweet shop usually has different varieties of sweets. Even I have different varieties like Mysore Pak's, laddus and jalebis arranged in the shelf. And if I have to check what would be the fraction of the space occupied by laddus in the shelf, how would I find out? Can you all guess? Now, how much would that be? 1 by 3, because if I consider these three shelves as 1, 2 and 3, laddus occupy only one part of 3 shelves. So the space occupied by laddus in the shelf would be 1 by 3. Now, as a shopkeeper, if I have expect or I want or I have sold assume 8 laddus out of the total number. How many numbers are there? How many number of laddus are there? 1, 2, 3, 4, 5. 5 and 4 rows. 5 columns and 4 rows gives me 20, correct? Out of 20 laddus, I imagine that I want to sell 8 of them. So what would be the fraction? Yes, fraction of laddus sold would be, now it is 8 out of 20, correct? So I would write the fraction as 8 by 20. I hope all of you have understood, children. Now moving on to the exercise 5.1. The first problem here, write the fraction for the shaded part in each of the following figures. Now if you observe the first figure, we have totally 7 leaves. So out of 7 leaves, we have 4 leaves shaded. So the fraction for the shaded part is 4 by 7. Now for the second figure, we have totally 9, and out of that 2 objects have been shaded. So 2 by 9 is the fraction. Out of 10, we have 7 flowers being shaded. So 7 by 10 is the fraction. Now moving on, 9th problem. Now for the first one, I am supposed to color 1 by 5. If you observe, we have 5 groups or 5 segments being divided. The whole group is divided into 5 segments. Okay, in that I am supposed to color only one part. So 1 by 5 is shown in the way we have colored it. Now for the second one, 2 by 3. So this is 1. This is the second part. So out of 9 segments, I am supposed to color only 2. This is 1. This is 2. Okay. So we have completed this. Then moving on, represent the given fraction by drawing a line. So what is the fraction? Now what is 1 by 3 of 12? Okay, now we will there are 2 ways here. See, diagrammatically we can divide, and along with that we will divide by calculating it also. Shade just one part. Okay, this is what is being expected. This one part is shaded. Now to calculate 1 by 3 of 12 is written as 1 by 3 into 12. Now, if you observe, 3 1 times and 3 4 times is 12. So what we get is 4. If I have to color individually, not considering the group, then also these are the numbers 1, 2, 3 and 4. I've got the answer now. Okay. Now moving on. So part it or divide it or mark 2 groups out of 5 groups. This is the answer. Now for the calculation part, as we did it earlier, 2 by 5 out of 15 or 2 by 5 of 15 can be written like this. Now 5 1 times, 5 3 times. Now 2 into 3 is what we need to write, which is 6. Now children, if you observe, it is 1, 2, 3, 4, 5 and 6. So totally the answer is right. Now out of 7 groups, I am supposed to mark off 2 segments here. So 2 segments come up to this. Okay, this is the shaded part. Okay, now for the calculation. Now it says 2 by 7 out of 21 or of 21. 2 by 7 of 21 can be written as 7 1 times, 7 3 times. Now 2 into 3 is what we need to calculate. 2 3s are 6. So 6 is the answer. Now children, if you observe, 1, 2, 3, 4, 5 and 6. Got it children? Moving on to the next problem. Shade the figures to show the fractions. Now they have given the fraction and we are supposed to shade it. There are totally 11 pictures here. The denominator says 11. So out of that, 6 needs to be shaded. Now similarly, 7 out of 20. Now for the next one, 8 by 15. 8 out of 15 needs to be shaded. So totally 8 pictures being shaded. I hope all of you have understood children. Now moving on. Which of the following shaded figures represent 4 by 9? Now for the first picture, see, if you observe, the total number of segments are 8. So the denominator becomes 8. Then that is the reason we will not consider this. So this picture will not give us the actual fraction what we want. The second picture has denominator 9. Yes, we wanted that. Numerator, how many squares or how many rectangles have been shaded? 1, 2, 3, 4. So 4 by 9 is the fraction what we want. So the second figure satisfies that. Now the third one, though we have total as 9 in the denominator, but the shaded part is only 3. So we don't want to consider this figure. Now again moving on to the next one, the total number of fraction itself is 12. So denominator becomes 12. We don't want to consider that. Now next, figure 5, the denominator becomes 6. Hence we will not consider that. Now for the figure 6, the denominator is 9 and total shaded part is 4. Okay, this is the fraction which we want. We can, which satisfies the number which has been given. Figure 7 has denominator 9 and 4 parts has been shaded. Yes, figure 7 also satisfies the fraction. So the condition the figures that satisfy the condition to have a fraction of 4 by 9 is figure 2, figure 6 and figure 7. Now moving on children, which of the following shaded figures represent 5 by 12? Discuss the reason. Okay, see, in the first figure both of them doesn't satisfy. Shaded part is just 4 and we have numerator as 5. So it doesn't satisfy. Okay, now next 1, 2, 3, 4, 5. 5 is the numerator and the denominator is 12. So it satisfies. Okay. Now justification is what we are discussing now. When the denominator, the total object is divided into 12 segments, so that becomes the denominator here, and numerator is the number of segments that are considered, that are shaded here. Okay, that comes up to 5. Hence this figure can be considered. Okay, similarly when you go to the third picture, though the denominator goes to 12, but numerator is not 5, it is 4, so this cannot be considered. Now again D, the fourth figure, this also satisfies our condition of 5 by 12. 12 is the total segments and 5 is what we have considered. Now for the fifth diagram, though 12 is the denominator that are segmented, then 4 becomes the numerator, which is not okay. So we will not consider that. Yes. Represent the grouped parts as fractions. There are 3 triangles in the group and 1 outside. So there are totally 4 in this box, and that is what is to be considered in the denominator. Similarly, if we have to solve this, see in the box how many are there, so that comes up to the denominator, and grouped segments are 4. So 4 by 5 is the fraction. Now next one, 1, 2, 3, 4, 5, 6, 7 is the denominator, and 3 is grouped. 3 by 7 is the fraction. Now 6 is the denominator and 5 is the numerator. Now let's know more about comparison of fractions. Now what is comparison of fractions? It is just knowing whether one number is greater than or smaller than the other number. The number here considered, whichever is considered, is fraction. So we are comparing two or more fractions, whether they are greater than or smaller than each other. Now to compare these fractions, we have few conditions, or we have few principles that needs to be followed. We can segregate it in those manners. The first one being comparison of fractions having same denominators. What if 2 fractions have same denominators? How do I compare them? Now for that we have a set rule. If fractions have the same denominator, then smaller the numerator, smaller is the value of the fractional number. Similarly, greater the numerator, greater is the value of the fractional number. Now let's understand this by working out few examples. Now look at these 2 shaded parts of the following figures. The first one being 1 by 7, that is one part being shaded among 7 equal parts which are divided. Correct? So it is just one part which has been shaded, and here we have 3 parts being shaded out of 7. Here children, the denominator is the same. Now are the shaded parts of each figure equal in size? Yes. But well, what is the shaded part fraction that we need to consider, and which one is lesser than or greater than? As per the definition here, smaller the numerator, smaller is the value of the fractional number. Now we will check on to the numerator. Here 1 is less than 3. 1 is less than 3. So smaller the numerator, smaller is the value of the fractional number. So 1 by 7 is smaller than 3 by 7. Symbolically, I write it as 1 by 7 less than 3 by 7. I hope all of you have understood. Let's move on to another example. Now here also, if you observe, the denominator is the same. Numerators are different. So as per the definition, smaller the numerator, the smaller is the value of the fractional number. Greater the numerator, greater is the value of the fractional number. Here 5 is greater than 3. Therefore, 5 by 8 is greater than 3 by 8. 5 by 8 is greater than 3 by 8. I hope all of you understood, children.
Now moving on to the second condition, comparison of fraction having same numerators. Now the previous one was fractions having, we compared fractions having same denominators. Now it is fractions having same numerators. So if fractions have the same numerator, then what is the condition that we need to consider? Greater the denominator, smaller the value of the fractional number. Similarly, smaller the denominator, greater the value of the fractional number. I hope all of you have got it, children. Now we will understand it with few examples. We have two figures here. The first one is a rectangle which is segmented into 5 equal parts, whereas the second figure has a segmentation or division of 8 equal parts. Did you observe, children? Both have different denominators. Now, what is the numerator? Numerator is the same. Here it is 3 parts out of 5, but here 3 parts out of 8. Now, which shaded part is greater? Now, as per the rule, greater the denominator, smaller the value of the fractional number. Smaller the denominator, greater the value of the fractional number. Now, similarly, 5 is less than 8 in the denominator. Hence, 3 by 5 is greater than 3 by 8 because of the rule what we have understood. 3 by 5, 5 is of lesser value, correct? So, the smaller the denominator, greater is the fractional value. But whereas 8 is bigger than 5. So, the rule goes like this: greater the denominator, smaller the value of the fractional number. Hence, 3 by 5 is greater than 3 by 8. Did you all get it, children? Yeah, moving on to another example. Now, in this two circles, these two circles, wherein one is divided into 6 parts, the other one is into 4 parts, but the numerator is the same. Both have 2 parts shaded in each of them, but which is greater? Which shaded part is greater? This we need to find out. 2 by 4 is greater than 2 by 6. Symbolically, how we write? 2 by 4 is greater than 2 by 6. I hope all of you have understood, children. Now we shall work out few problems from exercise 5.2, page 63. Okay, to start off, 12 by 21, whether it is less than or greater than 12 by 15. Yes, children, can you answer along with me? It is less than 12 by 15. Now for the second one, 11 by 17, 11 by 15. Both the numerators are the same, but denominator 17 is more than 15. So 11 by 17 has to be lesser than 11 by 15 because greater the denominator, value of the fractional number becomes less. 6 by 11 is greater than 6 by 15 because 15 is greater than 11. Now next, 4 by 23 and 5 by 23. Both the denominators are the same, but numerators are different. 14 is more than 5. So when the numerator is more, then the whole fractional value gets a higher value. So 14 by 23 is greater than 5 by 23. 17 by 20 is greater than 12 by 20. 11 by 15 is greater than 8 by 15 with a similar rule that we have been following. To the next concept, equivalent fractions. Fractions which indicate the same value are said to be equivalent fractions. If you observe the figure, there are three circles and each one is divided into different number of sections. For example, the first one is exactly divided into half. That is, only one part is considered out of two because the whole circle is divided into two parts. That goes to the denominator and only one is considered because one is shaded. I take it as half. The same thing for the second figure. How many total divisions are there? 1, 2, 3 and 4. So totally it is 4 divisions, but how many are considered? 2 divisions are considered. So 2 by 4 is the fractional number that we get with this figure. Now going on to the next figure, the total figure is divided into 1, 2, 3, 4, 5, 6, 7, 8. Totally it is divided into 8 sections. That goes to the denominator. Then numerator is 1, 2, 3, 4. Only 4 parts are considered. So the fractional number is 4 by 8. Now if you observe all the three fractional numbers, all seem to be equal because see 2 by 4, 1 by 4 cannot be reduced to any further level. 2 by 4 can be reduced to 2 1 times, 2 2 times. So this also becomes half. Now 4 by 8 can be reduced to 4 ones are 4 twos are 1 by 2 again. So if you observe, all three fractions are the same. So fractions which indicate the same value are said to be equivalent fractions. Understood, children? Now, if I'm given a set of figures and I'm asked to, or a set of numbers and I'm asked to find the equivalent fractions, then how do I do it? That is also to be known. Now, if you observe the following figures which are mentioned here, what is the fraction that can be written? This is 1 by 3, correct? The second one is 2 by 6. The third one similarly is 3 by 9. I hope all of you are getting it, children. Fourth one is 4 by 12. Did you get it? That is, I have 12 divisions and out of that only 4 are shaded. Here also I have 9 divisions and out of that only 3 are shaded. I hope all of you have got it. Now, I claim that this is equal to each other. All 4 fractions are almost equal. They are equivalent fractions. If at all I don't know whether they are equal or not, or if I have to find a equivalent fraction for the given fraction, for example, if I am asked to find out an equivalent fraction for this 1 by 3, how do I find it? So to find equivalent fractions, multiply the numerator and the denominator of the fractions by the same number other than 0. Children, make it very clear in your minds that you have to multiply both numerator and denominator with the same number. But this number should not be 0. Other than 0, you can multiply both numerator and denominator with the same number to get an equivalent fraction. Now, let us check how we do it. Now, if I take up the same fraction here, 1 by 3 was the fraction which we started with. Now, as I said, I multiply both numerator and the denominator with the same number. Okay, if I multiply both the numerator and the denominator with the same number 2, what do I get it? Now, if I have to multiply 1 into 2, this becomes 1 into 2 divided by 3 into 2, correct? Now, what is this? 2 into 1 is 2 divided by 3 into 2 is 6. Now, what is the fraction that I have got here? It is the same one, right? Now, we shall try for the third one. 1 by 3, as I said, I am multiplying with the same numbers both for numerator and denominator. Let me try another number now. 2 we have completed, I'll try with 3. Now this becomes 1 into 3 and 3 into 3. 1 into 3 is 3 divided by 3 into 3 is 9. Now what is the fraction that I have got? It is 3 by 9, correct? Similarly, for the fourth fraction also, 1 by 3 into 4 divided by 4 is equal to 1 into 4 divided by 3 into 4 is equal to 4 divided by 12, which is again the fourth fraction what I have got. Hence, all these fractions are equivalent fractions. So from 1 by 3, I could find a 2 by 6, 3 by 9 and 4 by 12 as equivalent fractions. How did I get it? I multiplied both numerator and denominator with the same number other than 0 and hence I got the final equivalent fractions. I hope all of you have understood, children. Now, for an example to clarify, write two equivalent fractions of 3 by 7. Like 3 by 7 is the fraction. Now, how do we find equivalent fractions? As we discussed it earlier, children, we will multiply both numerator and denominator with a same number and find out the equivalent fractions for this. Now to start off 3 by 7, first I can multiply 3 by 7 with 2 for both numerator and denominator, and the answer what I get is 3 into 2 divided by 7 into 2. 3 into 2 is 6 divided by 7 into 2 is 14. Similarly, to find out the next equivalent fraction, I will have to multiply both numerator and denominator with 3. Now 3 into 3 divided by 7 into 3. This comes up to 9 divided by 21. Therefore, the equivalent fractions are 3 divided by 7 is equal to 6 divided by 14 is equal to 9 by 21. I hope all of you have understood, children. Now moving on. Now how do we check for equivalence of fraction? How do we check whether the two fractions which are given are equivalent fractions or not? So there is a condition that we need to follow. Okay, if you follow those principles, then it's easier to find out. If two fractions are cross multiplied and the products are equal, then the fractions are equivalent. So when two fractions are given and asked to you and you are asked to find out whether they are equivalent or not, you just have to cross multiply and find out the products. And if the products are equal to each other, then the fractions are equivalent. Similarly, if the two fractions are cross multiplied and the products are not equal, then the fractions are not equivalent. Understood, children? Now we'll just work out an example to understand how it actually works. Now 3 by 4 and 9 by 12 are two fractions. Now as per the condition, we will have to cross multiply both of them. Okay. Let's see what happens. 3 by 4 and 9 by 12. I need to cross multiply. Okay. If I cross multiply, then what is the product that I get? Now 3 into 12 by cross multiplying numerator and denominator. Then second one is 4 into 9. So 3 into 12 is 36. 4 into 9 is also 36. Therefore, if you observe both the fractions, the product of both the fractions are equal because both we have got it as 36. Therefore, 3 by 4 is equivalent to 9 by 12. 3 by 4 and 9 by 12 are equivalent fractions. We even write it as 3 by 4 is equivalent to 9 by 12. Now, we'll check up with another example. We have it here 2 by 7 and 6 by 9. Again, we will have to cross multiply. If we cross multiply, then the product what we get is 2 into 18 is 36. 7 into 6 is equal to 7 6 times is 42. Now children, if you observe, 36 is not equal to 42, is not equal to symbol is like this. So 36 is not equal to 42. Therefore, the fractions are also not equivalent. So 2 by 7 is not equivalent to 6 by 18. This can be written as, therefore, 2 by 7 is not equivalent to 6 by 18. I hope all of you have understood, children. Now moving on to the next concept, finding equivalent fraction with given numerator and denominator. Children, till now we were finding both numerator and denominator. Rather, in fact, we were supposed to find another new fraction, equivalent fraction, correct? So, but here what happens is we are given numerator, or we could be even given denominator, and we would be asked to find the numerator. So, for example, this is the first example which we are taking. 2 by 5 is equal to, there is a blank space there, and below that is 15. So how do we calculate? As I told you, to calculate or to find an equivalent fraction, we need to multiply both numerator and denominator by a single number. Now if you observe, I have got a product for this denominator, which is 15. To get 15, what should I multiply 5 with? 3, exactly. 5 3s are 15, right? So, to find an equivalent fraction, I need to multiply both numerator and denominator with the same number. So, I multiply the same number for the numerator also. So if I multiply, what do I get? 2 into 3 is nothing but 6. So this block can be filled with the 6 number. Understood, children? Now we'll work out another example so that you have a better understanding of this. Here, if you observe, the denominator is left blank. Okay. Similarly, 3 by 7, I need to multiply both the numerator and the denominator with the same number. So if I have to get 12, what is the number that I need to multiply the numerator with? 4. 3 fours are 12. Correct? Now, similarly, I need to multiply the denominator also with the same number, irrespective of what number I have next to it. Correct? So, 3 into 4 is 12. 7 into 4 is 28. So, this is filled in the blank. Understood? So, 28 is the number that goes in the blank. Now going on to exercise 5.3, page 65, children. You can complete it all by yourself, but still we will just discuss the answers along with, you can start working along with me. First problem, 2 by 3 is the first fraction which goes up to 4 by 6. That is 2 into 2 and divided by 3 into 2 is the next operation, for which we have got 4 by 6. So to find the next equivalent, 2 by 3 can be multiplied into 3 for both numerator and denominator, which would give me 3 twos are 6 divided by 9, which I think can be filled here. Denominator is 9, numerator is what we have found out. Then the fourth equivalent fraction, 2 by 3, can be multiplied into 4 on both numerator and denominator. 2 fours are 8, then 4 threes are 12. 12 is to be filled in the gap. Got it, children? This working was for the first problem. Now for the second problem, 5 by 7 was the first starting fraction. Then we have got 14 in the denominator. If I have to get 14, then 7 into 2. So 5 into 2 is what I carry out the operation as. 5 twos are 10, 7 twos are 14. So 10 is to be filled in this gap. Then again, the next equivalent fraction. So 5 by 7 into 3 on both numerator and denominator, I get it as 15, which is already there in the problem. There is another gap in the denominator that I need to fill. 7 threes are 21. Now for the next gap to be filled, 5 by 7 is equal to, if you observe, the next gap is 40. Okay, the denominator has to be 42 and similarly the numerator has to be filled. So if I have to get 42, then I have to multiply 7 into 6. So 7 6 times is 42. Similarly, 6 has to be multiplied to the numerator also. So 5 6 times is 30. So 30 is the answer for the numerator there in the block. I hope all of you have understood, children. Now moving on to the next problem. This set of equivalent fractions we need to find out. First one being 2 by 5 and the second one being 4 by 10. This 4 by 10 is got by, okay, we'll write it in that manner so that it is easily understood. So it has to be 2 into 2 divided by 5 into 2. Then 2 into 3 divided by 5 into 3. 2 into 4 divided by 5 into 4. Similarly, last one is 2 into 5 divided by 5 into 5. Okay, children? See, if you observe 2 into 2 is what you have got it here. So similarly, for this, you need to get it as 2 into 3 is 6 divided by 15. 8 divided by 20. Now for the last one, 10 divided by 25. I hope all of you have understood. Now similarly for the second one, 3 by 8 and 6 by 16. How did we get 6 by 16? 3 into 2 divided by 8 into 2. This we got it as 6 by 16. Similarly, 3 by 8 I've multiplied into 3. So what do we get? Yes, 3 times is 9. 8 threes are 24. Is 3 into 4 divided by 8 into 4. So here we have 9 divided by 24. Now 3 fours are 12. 12 divided by 32. Similarly, 4 fours, 5 times is 15 divided by 8 5 times is 8 fives are 40. Now for the third one, I think you can do it directly. 9 by 11 is what you start with. Then 9 into 2 is 9 into 2 and 11 into 2 is what you get as 18 by 22. Then 9 into 3 is 9 threes are 27 divided by 33. Then 9, next step is 9 fours are 36 divided by 44. 9 fives are 45 divided by 11 fives are is 55. I hope all of you have understood this, children. If you work out along with me, it's easier for you to understand. Now for few assignment problems. I have just taken out problems from the exercises which are there in the textbook itself, half of which we have discussed in the class, the other half I have given it. So this is first main, fill in the blanks, fill in the gaps using greater than or less than symbol, which we worked out. Similarly, you also have to find out using all the principles and rules. Now finding the missing fractions, we have done it. Similarly, you need to work out. Now for the third main, write down the equivalent fractions for the below figures. This is the first figure. You have two figures in this. You need to write the fraction for this first figure and then fractions for the second figure as well. Both are equivalent fractions. Now this is the second figure. With this, we complete the chapter fractions, children. I hope all of you have understood. Please answer all the assignment problems given. Solve all the problems so that you get acquainted with whatever new concepts that are introduced. Stay home, stay safe, happy learning, and thank you, children. Bye bye.